So, welcome back. Let's quickly glance through that what all we have covered in our previous discussion. So, we were talking about the textbooks and some basic topics. We looked into the basics of software engineering, why actually it is required, and then what basically a software is, then why there is a need of documentation, and then we were talking about the basic definitions of software engineering, and then the list of people who actually use these softwares, and then we found that okay, it is very tough to identify that who all are not using uh, the softwares. And then we started talking about the quality attributes, where we were talking about all those NFAs, right? You can recall that this was something which was your non-functional attributes. We'll separately talk about all these non-functional attributes in our upcoming classes. And in some of the literatures, you'll also find it as, uh, you know, as your NFRs. That means non-functional requirements. So don't get confused if suppose someone is using NFA or someone is using NFR. So both the things are almost the same. Then we started talking about all these X abilities like reliability, extensibility, maintainability, performance, then usability, security, availability, and portability. So we had a discussion on reliability, then we looked into what basically this extensibility and maintainability is. Then we looked into a very important non-functional requirement, which is your performance, and then we saw what basically the usability is. Then we looked into various concerns related to the security aspect, and then we were talking about availability factor. So this was all about the topics which we have covered in our previous lecture. One thing to note is that availability is of utmost importance in case of your applications running in the healthcare division and applications running in financial transactions. Just imagine a patient going for, let's say, MRI, and all of a sudden my application, which is the backend application which is running and making my hardware run, goes unavailable. Just imagine the situation. Similarly, in case of financial transaction, if suppose you are making a financial transaction and all of a sudden your application software application becomes unavailable, then how tough it becomes for to go for the settlements and all. Many times you observe this, maybe due to some software induced error or maybe due to some network related issues, you find that the transaction fails, right? Your application becomes unavailable, not because of the errors which are there in the application, but maybe due to some external reasons. That can be your connectivity issues or maybe power related issues and so on and so forth. So in that case, what you do is, if suppose your transaction fails and then your payment is half done, that means it gets debited from your account, and it does not go to the Amazon or Flipkart's account. So in that case, your transaction fails and you have to wait for 2 to 3 to 5 days, sometimes even, in order to get back your money. So that's how important aspect is this availability. So this was all about the things which we did. Let's talk about some new topics in today's lecture. So portability, right? Once again, a very crucial factor. So portability of a software is the degree of ease with which one can install and use that software in different environments. For example, your Java-based programs run on all the operating systems that support your JVM without modifying even one line of code. Right, so it's like on all different environments and platforms, my application is available to work, right? So portability factor should be very high, right? So this should be on a higher side. So typically software is designed in such a way that except for one layer of that software, all other layers do not need any modifications when that software is ported onto different OS or DBMS or any other hardware component. So it's like your business logic layer remains same, right? Your business logic layer remains same, because see, if there is a calculation of cost price plus GST, this will remain same irrespective of any of the environment, right? Or if there is a tax calculation, so a person under the slab of let's say 20%, right? So he or she will remain in the say slab of say 20%, irrespective of what kind of platform my application is running on. The only thing I need to take care of is the compatibility, right? The portability factor. That's why it is said that a particular application's portability should be very high. And let's now talk about your productivity part, right? So this is something also which is very crucial. So this is on the other aspect, that the average number of LOC per person. This LOC stands for lines of code taken over the complete life cycle. We'll talk about life cycle, which is your SDLC, to be very specific. That is your software development life cycle of a software project, which is well engineered projects eliminate or minimize the redesign or recoding or retesting, and thereby achieving high productivity. So we need to use the engineering models and the methodologies and the standard tools plus the training of personals in order to contribute towards the high productivity, right? So productivity is something which is related to, if suppose I am following certain standards, certain procedures, so obviously I expect to be very productive, right? So next one is cost. Once again, I need to follow those standards and all. So appropriate balance between high productivity, as I said, right here also we need to look for productivity, and high cost is very essential. So high productivity and low cost is a dream of every software manager, right? This is what, like, I am able to provide you the services of, let's say, you know, a Mercedes car, right, for the cost of a Maruti's car, right? In that case, it's kind of dream, right? So productivity is high and the cost is low. So that's, just imagine how crucial this thing becomes. So once again, I would say that it's impossible to compare an apple with banana, right? So definitely the cost factor comes into picture, and your productivity also comes into picture. Let's assume, like, if I'm talking about the facility provided by, let's say, a car which is your let's say Lamborghini's Miura, right? In that case, the facilities provided by your Maruti 800 will not be same, right? But at the same time, uh, Maruti 800 is satisfying some customers, Lamborghini Miura is satisfying some customers. So here the quality is associated with the cost, right? So quality is associated with the cost. So that's how it is compared, right? So I cannot compare these two models, right? A Maruti's and a Lamborghini's, right? So in that case, I have to take consider the pricing as well. Of course, I can compare Maruti 800 with maybe Eon, or maybe, let's say, I can compare it with your, let's say, Santro up to some extent. But yes, of course, no comparison in these cases. So as I said, the cost and the productivity and the quality. These things are to be considered, keeping in mind all these factors. Right. Now let's now talk about something different, right? Because we saw the need, we saw the quality attributes, your all the non-functional attributes, and let's now talk about software crisis of 1968. And not only in 1968, there were several issues, like there were history of software failures and losses. So in the year 1996, I remember it was like one of the largest bank of US credited accounts of nearly 800 customers, and it was credited with approximately uh, you know uh, several lakhs of dollars. So later on, it was detected that the problem occurred due to a programming bug in your banking software. So this was one of the issue related with the bug which was there in this particular thing. In the same year, 1996, we had this particular Ariane 5 space rocket. So Ariane 5 space rocket was there, and this was developed at a cost of $7,000 million, and it took nearly 10 years to complete it, and it was destroyed within less than a minute after its launch. And this particular crash, it occurred because there was a software bug in the rocket guidance system. So that's something which is heavy loss. And similarly in the year 2000, everyone is aware about Y2K problem. I guess you might be aware about Y2K problem. So this particular thing refers to the widespread snacks in processing data after the year 2000, right? So post 2000, the problem was everyone thought that okay, it was in 1990s, right? So what will happen if I'll reach to 2000, right? So that can be tracked back to 1960 to 80, where the developers shortened the 4-digit date format to a 2-digit format. It's like because this will have the advantage of saving memory, but people did not realize that when 2000 will be shortened to 00, so it's like 2000, so this will be shortened to 00, right? And this is like something which is causing trouble, because in that case 2000 and then 1900, so both are 00s. Then the storage problem as well. So in the 1990s, experts they began to realize this major shortcoming in the computer application, and there was some advantage, like lot many people got jobs just because of this, like bringing frequent changes to the software application, that has resulted into lot many jobs as well. Then somewhere around the year 2003, another issue was there, where the northeast blackout was there. So it was one of the major power system failure in the history of North America. So this blackout involved like nearly 100 power plants, due to which almost 50 million customers faced power loss, which resulted into the financial loss as well. Obviously, that was close to $6 billion. So just imagine how huge loss it was. And later on, it was determined that the major reason behind this failure was a power bug which was monitoring and managing this particular system. So this was like in 1996, and then 2000 and 2003. So let's talk about 1968. So this particular topic came from a NATO conference. So during 1960s, there was so much progress in the hardware technology and the production, that is the engineering, that the business community was offered more powerful hardware boxes at a very lower price. But in the area of software engineering, it particularly failed to meet the expansion plans. What would the business community do with the powerful hardware boxes without the suitably matching, which is like your reliable, high performance software packages being available, and many of the software projects had time and cost overruns as well. So this situation was declared as software crisis by F.L. Baur at the first NATO Software Engineering Conference in 1968. It was there in Germany. So this was an early use of the term in Dijkstra's 1972 ACM Turing Award lecture. And since then, there has been a great focus on software engineering. Right. So what happened was that there were rapid changes in hardwares, and there was a rapid change in the standards which were given for the hardwares, but it was not the same as the case of softwares. As of today, right, you can go to, let's say, Ricer Plaza, you get a RAM. Right. You go to, let's say, Gaurav Tower, you get, let's say, a CPU. Right. On your motherboard, to be very specific. Fix those two things and add your extra components, your power unit, and you will be able to get a complete computer system, right? And it will be up and running. So that's how these standards are there in case of hardwares. But let's say I'm talking about your MIS system. You go to Ricer Plaza, bring a CD of, let's say, course registration. You go to Gaurav Tower, get a CD of, let's say, attendance management system. Add it and get an MIS. Is it possible? Of course, no. Software integration, lot amount of issues. Software development, standardization, still lot amount of issues. Right. So that's how we saw the emergence of software engineering. So the problems of and progress of software engineering in 1968. So the large programs with go-to statements and global variables existed. So Dijkstra had brought into the go-to less block structured programming concepts as well. Lot many go-tos were used previously, and then we have like reusable functions with parameters and local variables were introduced, leading to the modular programs and reinvent libraries. Right. Reusability factor comes into picture here. People started focusing on reusability of code as well. Use of files for storing and retrieving data was replaced by database tables now. So from file systems, we started moving towards the database management systems. So whether it was hierarchical, networked, or the relationals, this enabled locking at the table or the row level, thereby paving way of concurrent use of software packages. Right. So concurrency is something which you might have studied in your DVMS course as well, right? Concurrency management, concurrency control, and all. Relational database concepts had led to a scientific way to design databases. That means eliminating the artistic flavor of software engineering of 1970s and 80s. There has been great focus on software engineering since the software crisis event. Right? People do take care of data to be modeled in a way so that it helps us in various kinds of updation, whether it is insert, delete, or some smaller updates. Now, so this software engineering models like your SSAD, OAD, FDSE evolved. Then we saw the case tools emerging and leading to the IDEs as well, your integrated development environment. So object-oriented software engineering was a major breakthrough, offering encapsulation and your software services, leading to the major improvement in quality. So whenever we are talking about object-oriented, so all those features like encapsulation, data hiding, polymorphism, data abstraction, all these things comes into picture. Your BPM, BRMS, SOA, JMS, web, these things had offered the next set of improvements as well. Business process modeling. We'll talk about BPM and BRMS as well. Service-oriented architecture. So these things we'll see in the upcoming lectures as well. But still, there are problems which we are still facing. Right? So design of a program modules has still a part of art component which is not desirable because everything should be well engineered. Lack of international standards as compared to the electronics and communication engineering, right? As I said, in hardware it exists, in software it is not. So this is coming on the way of plug and play capability of software packages. Yet, once again, we would like to throw some light that yes, still we have focused a lot on these aspects as well. Now, let's talk about the current state. Now, what the current state is that there are at least 1 billion people in today's world who depend on upon uh, throughout 24 cross 7 on cell phones. Right? You just go to your cell phone and see the screen time. Right? Screen time, and on top of it, screen time, that means the time you are using your screen. So this would be, I assume for you people, this would be more than 5 hours per day. Right. So 5 hours out of 24 hours. Just imagine, you know, how much time you're paying towards your, cell phone screen. And on top of it, like at the back end also, it keeps on working. Right. Then we have like ATMs, your Airtel travel. You're using your Google. You're using TV channels. Then we have retail shops working 24 cross 7, billing and everything. Your electronic devices, where a software package is continuously working. So this is the current state, that anything and everything will have a software induced in it. Some of the software packages have, nearly 30 million lines of code, 30,000 classes, thousands of modules, and these things will be interacting with each other using 1,000 database tables, 1,000 GB data, and processing 50,000 transactions per day with more than 99% availability. So just imagine the potential of this software usage. Right, just imagine the potential of this software usage. Still, only one software package in the last 40 years has won the Malcolm Baldrige Award so far. So we already had a discussion on this Malcolm Baldrige Software Awards, and just imagine that we have only one product from the software industry. So now the point is that after all these things, what is the next set of big things? So building software from tested building blocks, that is integrating with ease a set of required services into a software package with no or minimal testing, just as we assemble compatible hardware parts into a system and start using it. Use and pay of software packages with both software and data on the cloud. Right. So cloud computing, we have already seen cloud computing and its usage at a very high scale. Right. Now what we are trying to do is that this is something which is the next big thing. That means I need to focus on plug and play kind of thing, simply assembling, integration. Plus, software testing requires a good amount of investment. Testing a software is a costly affair. So this should be reduced, right? So this particular thing should be reduced, because a costly affair and a time consuming affair as well. So I should have a kind of application where I can simply assemble it, and just like in the case of your hardware components, assemble it and use it. Now let's talk about the software engineering ethics. So software engineering involves wider responsibilities than simply the application of technical skills. Software engineers must behave in an honest and ethically responsible way if they are to be represented as professionals. Right? This is something which is crucial, very crucial. Ethical behavior is more than simply upholding the law, but involves following the set of principles that are morally correct as well. Right, so these are some of the software engineering ethics, and on top of it we have some responsibilities as well. As a software engineer we have certain professional responsibilities as well. Let's see what basically it is. So one is confidentiality. Right, so engineers should normally respect the confidentiality of their employers or clients, irrespective of whether or not a formal confidential agreement has been signed. So normally we sign this NDA, right? Now the point is what basically this particular NDA is. Here also we are talking about confidentiality, right? And in case of applications, that means we have to keep certain things confidential, whether it is done formally or not, right? So in that case, many times you observe that in the formal presentation we go ahead with signing this particular NDA form as well, right? So it is your so this NDA stands for your non-disclosure agreement. So this NDA form you normally sign when you're taking up software assignments and some data is assigned to you. Now next is the competence, right? Engineers should not misrepresent their level of competence. They should not knowingly accept work which is out of their competence as well. So that's a part of your professional responsibility, and it is something which is ethically correct as well. Now next is your IPRs, right, which is your intellectual property rights. So engineers should be aware of local laws governing the use of intellectual property, such as your patents, your copyrights, etc. They should be careful to ensure that the intellectual property of employers and clients is protected. So it's like a simple IPR concept. Computer misuse, yeah. So software engineers should not use their technical skills to misuse other people's computers, right? Computer misuse ranges from relatively trivial game playing on an employer's machine to the extremely serious, like dissemination of viruses. Then your hacking comes into picture as well. So this is your ACM IEEE code ethics. We have preambles. You can read it. I'm not going to go into details of it. Then here we talk about your public, client and employer, your product, your judgment, your management, your profession, your colleagues, and yourself. So these are some of the IEEE coding ethics and the ethical principles. Yeah, so ethical dilemmas, disagreement in principle with the policies of senior management, well possible. You may agree to disagree, right? So your employer acts as in an unethical way and releases a safety critical system without finishing the testing of the system. That is something which is unacceptable once again. So participation in the development of military weapon systems or nuclear systems. So this is something which is very confidential, very confidential. So this was all about the introductory part, and let's quickly summarize it. So here we looked into what basically was the need of software engineering. We saw some quality attributes or the non-functional attributes or the non-functional requirements. We talked about software crisis, and we looked into what basically the current state is, and we looked into the engineering ethics as well. So now let's quickly summarize all these points. So a wide range of business and the scientific and the social organization depends on your complex software packages for the continuity of their operations, and we cannot afford another software crisis, right? We need to engineer software guaranteeing high quality at a very reasonable cost. And the software engineering is the process of manufacturing software using a set of well defined principles, techniques and methodologies such that the process is repeatable, independent of humans involved, and offers certain estimated values of quality of the product being manufactured, right? And then we need to be aware of and follow current software engineering models and research into better models as well. We need to be simultaneously ethical software engineers as well, right? So these are some of the critical software engineering points, right? And this was the overall summary. In the upcoming discussion, we'll talk about your SDLCs. Right. So SDLCs stands for your software development life cycle. So this deals with various software development life cycles. We'll start with your generic software SDLC, and then we'll see into various models, right? Which is your waterfall model and so on and so forth. So see you soon.